and welcome to another video. Today we have a contest on the platform that is the furthest from competitive programming, as we already found out during the previous months, which is HackerEarth, of course. As long as I'm concerned, there are not so many differences to this one, right? The only one that I spotted is that we have 5 problems this time instead of 6, I believe we had previous 2 times, but I'm not exactly sure. That's like, yeah. When you do a contest once a month, you don't exactly remember what happened the previous months, except for copy-pasting rules. But that's fine, that's fine. You know what, it didn't really stop us from solving most problems last time, or all problems. I don't remember what happened exactly, but yeah. Also, annoyingly, it does not have a timer, so I use Silas timer. And I also have a local compiling set up, just in case we need to test something locally. Because if you remember, one of the reasons why is a copy-pasting rule, which basically says that you can't copy-paste your code into the editor, and therefore you can't code locally and then just submit the file, is that their editor does not support C-error for debugging, and therefore you have to print to C out, and you have to comment it every time you want to make an actual submission, which is rather annoying. The contest is going to start any second now. Alright. Also there is annoying, but here it says 6 problems. Yeah, that is annoying registration form. And for some reason it actually says 6 problems. Okay, so the front page was a lie. Okay. Right. I don't remember if the problems are sorted. I hope so, but we'll see soon. So divide, I'm assuming the first problem, or is it the first problem? No, the smallest number is the first problem. Okay. First problem, smallest number. We are given a string S that represents a number. The string consists of the following characters: only 1, 2, 3. We can perform the following operation: swap any 2 adjacent characters if the absolute difference between the characters is 1. Alright. Our task is to determine the smallest number that can be formed by using the provided operation. We can perform this operation any number of times, possibly 0. Alright. It's not immediately clear, but I suspect that some somewhat greedy approach will work. Like, the thing is, you never can swap 1 and 3, and therefore in the resulting order, 1s and 3s will come in the same order that they do like in the initial order, right? So here, for example, all 1s were before all 3s, so that's the case in the result. But here the 1s and 3s were like 1, 3, 1, 3, and they come 1, 3, 1, 3 in the end. And therefore the question is basically moving the 2s to the optimal location. At least that's what I think. Yeah, and it's kind of small. Alright. that looks a bit better. Oh, actually I forgot to do also that. In case you see no differences, that's because like I assume that the brightness settings of my monitor, they don't get reflected in the recording, but in case you do see the differences, then it's a good thing that I did it now. Alright. So we have our string, and what we should do is move the 2's to the optimal location. So every 2 should come after all 1's that it can come after, but before all 3's. Is that the case? Wait a second. We can place 2's arbitrarily, right? So how about we do that? Yeah, we can swap 2 with anything. So we can't swap 1's and 3's. Therefore, I assume I don't know. I don't really know. Alright, should be like this. So we need a string that will hold the result, and the string to count the number of 2's. Whatever, let's just call it A. Not the best, but let's do what you gotta do. And what I believe we do is we place all 2's after the first group of 1's. Right? Because that's what makes the number the smallest one, right? Yeah, I've been thinking about it. I just want to do the STL way. So first is index, then count, then character. Oh, that is okay. Okay, you know what? That is just annoying. Okay. We'll do it the stupid way because you don't always have to be clever, right? So we'll just manually find the first 3. No, that was not the best way to do it. In result, I assume, but that's kind of okay. If it is not equal to string, not a position. Otherwise, I believe that we want to just print this. First comes the size, then the character. Should have a new line because we have several test cases. Otherwise, I believe that we want to do that. We want to split string at the position of the first 3 and print it in parts. Does that make sense? Hopefully it does. Oh, they also give us the length of the string, which I forgot about. Which we don't really need, but whatever. Okay, it appears that this passes. Okay, it got accepted. So, smallest number, right? I will just save it here for the sake of like publishing my solutions in one place after the contest. Alright, so second problem, we definitely spend a long time there, but that's okay. That's why the contest is 3 hours long. Because for people who woke up early in the morning, to not be very pressured by that. After all, it's not about who solves the first problem first, it's about who solves all the problems first. So, problem 2, divide the digits. Is it? Second problem, right. We're given a number n. We are required to form 2 numbers, x and y, such that the sum of frequency of each digit in x and y is equal to frequency of that digit in n. So we like partition the digits of n into, and the sum of numbers x and y must be minimum. Okay, our task is to determine the minimum possible sum of x and y. Can we have it is not clear. It's not clear. What about leading zeros? Excuse me. Where can I ask a question? Oh wait. Oh, they took it back. People, I just noticed like the previous times there was like a warning here and I took it back. Okay, so we definitely don't need that useless editor anymore. Although it's not that useless, probably. No, but I still don't understand what about the leading zeros. Like they don't mention. Let's say n is equal to 10. What's the answer? Is it 1 or is it what? Actually, if n is equal to 10, like, no, 10 is not, okay. 10 is equal 100. Yeah, actually, no, that's also not very interesting. No, but really, where can I ask a question? Because that's an important thing. Can I ask it here? No, that's useless. No, you understand how important leading zeros are for this problem, right? Right, so we'll try to skip that for now because I don't really want to solve a problem where I don't exactly understand the statement. So the third problem, count the array. We are given an integer p, we are given q queries of the following type. What does this n do here? Oh, n is the parameter of the... Who the fuck does it this way? Why? Right. Sorry about that, but that's What? Like you can't have a bulleted list with one item. What's the purpose of that? Okay. Determine the count of distinct arrays of size at most n and at least one, so non-empty, such that each array element is a prime number, and product of all the values of the array of elements is at most p. An array formed is palindromic. Whoa. Okay. Two arrays say to be, yeah, that's not interesting, not interesting. Yes. That's a lot of queries, my friends. Luckily no, wait a second. Well, luckily for us, n can't really be too big, right? N, it only makes sense to have n up to log of p, because even if you take all 2's, you take one too many of them, log plus 1, then you're already done. The product won't be what it needs to be. However, for this one I will copy paste, because there are 10 to the 5th squares, so this is definitely helpful. For the first one it didn't matter, that's why I didn't type it. Excuse me. Oh, that is... Alright. But can you please, like, is that the top, actually? No, that's... Well, maybe that's... Okay. So... First line contains P, second line contains Q. Oh, I'm too used to pressing Ctrl S. Sorry about that. Okay, so one based indexing does not matter at all, but okay. So what I think happens is that n can always get log of n. Should it be log 2? Let's say floats. But that should be precise enough for integers, right? Up to 10 to the 9th. No, let's not introduce anything, let's just do it this way. No, not log of p. And we should also say that it gets minimum of n and log of p base 2. No, actually, this one is kind of useful here. what I want to do is I want to well, first of all, I definitely want to know all prime numbers up to some point, right? So if this not, yeah, just your like regular sieve goes here. Alright, we got our sieve. Looks legit. Because we need, of course, all primes of p+1, I would imagine. Now, we clearly need all primes because arrays of length 1 is just the count of primes up to some point. And I don't know a better way of counting all primes than sieve, to be honest. So here we should have log +1. I assume because dp at so 0 is what? Is well, it's 0, so that's fine. But dp at 1 is sieve size, not sieve but primes, right? Prime size. All right. All right. All right. I wonder how many we can get, like, of length 2. Of length 2 we can, like, product is at most 1 million. Therefore, like, numbers that we multiply are at most 1000, right? Right. I wonder if we can afford the following. So instead of doing this, don't think that it's exactly necessary, but hear me out. We will calculate answer for all products for some miraculous reason, because I want to, like, use the condition that is palindromic in the following way. So when I calculate the number of arrays of length 3, I want to loop over the first element and then ask dp table how many elements in the second, how many subarrays of size 1 there are that satisfy the given condition. And I assume it's kind of quick because we don't loop over too many numbers and also we don't have too many layers, but we'll see. Oh, actually, yes. Why is it so difficult? Okay. I also want to know if number is prime or not. So dp at 1 and then product should get, what should it get? dp at 1 product minus 1 plus is prime product. Right? Looks reasonable. So that's the initialization of the first layer. Then we loop over layers. We loop over first element. And we ask her, well, if first times first no, we'll do it a bit differently. So the product is first times first, right? It's for the first element and for the last element. I also wonder if we should say that dp at 0 and product whatever gets 1. There's like one empty subarray. Right, we'll have to do something here, which I believe looks like this. Because dp counts of like exactly the given length, right? And what we want is we want of length up to something. So that will be of such length. So what I say then is for n from 1 all the way up to log, prefix sum at n gets prefix sum at n minus 1 plus dp at n and at p. Prefix sum of n gets modded, just in case. To be honest, I'm not so sure how the count can be very large, but okay. So, but this will come after we fill our DP table. Yeah, also another inconvenience, you can't hide that sync, which is just here, annoyingly, reducing your code editor size. But anyway, product, so we've taken the first element is equal to last, and therefore we take this. And then what we ask for is, I believe, wait, how does 7 come to be? Wait, no, we have to loop over all values of product or what? That sounds like it's going to TLE, right? But we'll see. Okay, so DP at n in product should get incremented by DP at n minus 2 and product divided by this sync. Now, if product is less than first times first, then we can break. That looks very sus. I don't know. I should actually say if this is equal to 0, then we can break, right? What? Where? 45? Oh, of course, PS is just a vector. Output 1010. Why did it happen so that we have 1010? I just wanted to see. Is it just me not syncing in the morning, or why is it so complicated? Yeah, so we don't see, okay, we don't see that. And we would like to see that. Maybe the problems are just not ordered, right? Count array. Count array say 10, 3, 4. P said that there is one way to have an empty array with product of at most any number, because the product of an empty array is always 1. Alright, makes sense. And it says that there is one way to have array of size. That is incorrect. That is, oh, of course, yeah, because s prime of 0 equals s prime of 1 equals false. For some reason I thought that we don't have to do that, but apparently we do have. Right, now it passes samples, let's get rid of that and submit. Oh, TLE'd in some cases. That is not good, that is not good. So you see, I see that there are 3 for loops. I was thinking that because first square grows kind of quickly, it means that, like, well, this loop takes 10 to the 6 times. This loop takes p times. This loop is log p times, and this loop is, because of this break, is square root of p times. And therefore we should have like of n of p, square root of p log p, which for certain circumstances can pass. Also, that is actually technically not square root, but square root of number of prime divisors up to square root. Which is a bit different, I wonder if we can ignore most of the numbers here. And instead have something like an ordered map from int to int. With the following idea in mind, so like there is one way to have an array Okay, so now we will say that it's like how many ways to have exactly given product, not like greater than or equal to, but exactly given product. The p0 at 1 is equal to 1. There's one empty array of product with product 1. For auto prime in primes, dp1 of prime is equal to 1. And we loop over that, we loop over that, we loop over that guy. So here is product, here is count. Right? That should be sorted. Can we say like if product times first, there probably should be some longs here, is greater than p, then we can break, right? Right. otherwise dp at n pro, yeah, like this is like, so if I assume it will look more understandable this way. So we have product of the rest, which goes in between, and we have first and last, which is equal to first. So if product is greater than p, then we break. Otherwise, dp at n product gets incremented by dpn minus 2, and like, no, but by just count, right? And also gets modded. This should be more efficient because the maps that we are having are relatively small. Like, because like in every such array, there is at most one prime number that has odd exponent. So like, for example, number 6 is never possible. It can never be a product. And I assume that plenty of more numbers can never be a product. Therefore, that should be a bit more efficient. However, it adds some lock factor, so I'm not sure if that is more or less efficient. Yeah, but I gotta try something, right? Alright, so we can also test this. And it did not compile. Yes, no, of course. That we can fix. Alright, so this actually works. Fantastic. I wonder what is the actual complexity, because I don't know, but apparently it works faster because there are not too many integers which can be a product of such an array. So this map is much smaller than the vector that was here before, and therefore this this loop is also takes much less time. Challenging problem. Maybe I missed something obvious, I don't really know. Let's see just how much behind we are, because in 40 minutes we could only solve. Oh, okay, so this is actually a challenging problem apparently for people. Yes, so only like 3 people solved it at this point. So yeah, the problems are misplaced as usual. Divide the digits. They say that it's not a hard one, but I skipped it because I don't understand the statement fully. So probably we'll try binary sequence, or is it... Should we just solve this one instead? Yeah, we'll go for divide the digits. We'll need my template for that. Do I have to do it every time? Are you serious? Like, that is very annoying, obviously. No, actually, yes. So what is clear is that you want numbers to be approximately of the same length. That's pretty clear. After that, you maybe we'll actually read a string can like this, right? Because why not? So what we are supposed to do first is build a frequency table, I think. So we look our digits of the number n. So like, okay, frequency digit minus 0 should be incremented. Sounds legit. What's next? We also surely we need length of our number. Or do we actually need it? I don't think that we need the frequency table, but what we can use is we can sort the string. Alright, so my idea is like, except for the first character, you don't really care which digit goes to which number, as long as they go to the same power of 10, and therefore S2E I believe will be sufficient, because the number has at most 19 characters and at least 1 2, so x and y are at most 2 times 10 to the 9th. Here I also don't need this. No, okay, I will use it, but that's like not necessary. I want to loop over that, and I say like, if I is this, then x plus equals ni, otherwise y plus equals ni, and I just print that. The digits are sorted in ascending order, so I place the smallest digits first, and I also alternate them between numbers, so that smallest digits go to smallest powers of 10. Alright, so actually they kind of don't care about leading zeros, which is a shame that we skip this problem, but okay. Alright, so back where we should be, I assume, if the leader bar refreshes. It kind of doesn't, but okay. Trying to gain information from the leaderboard. Looks like all of those are like not terrible, but I wonder why Nikita did not solve them yet. Because surely if this guy can solve the problem in 8 minutes, then Nikita should be able to solve it as well. Okay. So problem number 4, binary sequences. We are given 3 integers z, o, and k. Our task is to determine the number of distinct sequences of length 0 plus o that contain exactly z zeros and o ones. Also, the length of the longest non-decreasing subsequence in the sequence is of length. The length is of length at least k. Now that is actually a very bad wording, because if you treat a length as a string, then the length of the length actually makes sense. But I assume that that's not what you meant, right? Alright, that sounds like some combinatorics. This time we don't need to care about fast input-output. And I believe that it oh, here it's okay, that is just ridiculous. Alright. Why I can't lock as and set as default template? Does it help? Okay. Int z o and k. Z o and k. So you see what is the length of the longest non-decreasing subsequence, so that we have several zeros, several ones. Actually, I now kind of wonder how that guy solved it so quickly, because it does not appear to be obvious. But what we take is like, what is the longest non-increasing subsequence? We take some prefix, so we can always take all zeros, we can always take all ones, right? This kind of not decreasing. But what we can also take is, like here there are how many? Here there are 8 ones and 6 zeros. We can also take something like this, which is some prefix of zeros and some suffix of ones. And the length of this is also non-decreasing, and in this case the length is 9. The longest non-decreasing subsequence is some prefix of zeros and some suffix of ones. How are you guys doing on the leaderboard? Okay, so 3 people solved this problem. Interesting. So what I am thinking is that we need some cubic DP, because that just sounds very much like it. So here I have z plus 1, 1's plus 1, k plus 1, and all of those are initial zeros. All right. What we'll need is just this. So what I'm thinking about is like, if the first character, first integer, first element in the sequence is a 0, then it's always useful, like we can always take it into longest non-decreasing subsequence, right? If the first element is 1, then the only non-decreasing subsequence that it can be a part of by the way, we may just need we may need it to be another parameter. Interesting. No, I don't know what I'm doing. I'm just trying to come up with something. And a lot of parameters in DP sound like a good idea, usually. Because they are so small, I expect that I think that they expected something like this. Maybe not exactly like that, but we'll see. So, my idea is we count the number of sequences with I zeros, j ones, longest that with longest non-decreasing subsequence of length L, and that end at F, which is basically 0 or 1. How can we count those? That's an interesting question. I wonder what this F is supposed to be. I wonder if it's best that we solve problems in a different order, because that looks a bit overcomplicated. Like either I'm overcomplicating the problem, or it indeed requires a lot of DP. Just DP. Okay, so the fifth problem is select the subset. We are given an array A, an array A and B of size n. Who is B? If B is an array, then we are given two arrays, or like arrays, but not an array. So we must select a subset of indices from 1 to n such that for any pair of indices x, y, in the subset, one of the following conditions holds true. Well, I would suggest that you be explicit about other parts, like leading zeros, and not that. So either what? So they either compare the same way, or in the first array they are equal, but in the second array they are not equal. What the fuck is that? And n is up to 10 to the fifth. Right, so the last condition is kinda useless. It means that... Right, no, I actually think that we know how to solve it. It should reduce to something like longest increase in subsequence. In a rather clear way. Like, I don't exactly see how it is different, but give me a second. So we read an array A, read another array B, it was not the right choice. Do we need to print, yes, pair of 3 ints, please. So the thing is that we want to sort this body. Because, no, that didn't help. Setting as default template didn't help. Or maybe I should have refreshed page, I don't know, okay. Irrelevant. So we want to sort this body. And then we want to find longest increase in subsequence. But no, we just want to find longest increase in subsequence. What? I mean, we don't even need indices. I thought that we need them for something, but what? Like, That is not the proof. The proof actually usually goes like consider any subset and then it doesn't work. But yes, here it is more or less clear. Okay, no, I still have no idea why. I can't just compute longest increasing subsequence. I always forget, however, how to compute it. Luckily, I have this page. And luckily, I have. Yes, please. Luckily, I can copy paste it. I'll be extra nice and provide the source. Very bad. What are you? Okay. Minus the. Oh my goodness. Iterators should not be treated as pointers. That always ends badly. Believe me. No, actually, that was a reasonable choice. And I also believe that we can take negative of it. Oof, 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 oof. To be honest, I don't understand what's wrong with this solution. What? Okay, let's look. The sequence is 23, 56, 4, 3, 1. Oh, I definitely read vectors incorrectly. Yeah. No, but I mean, like, what's the trick? Lol, okay. No, but like for real, what's the trick? You just, like, elements in A determine like the priorities of elements of B, and then you want to find the list. In like, in a, they define a permutation to be exact. That condition sort doesn't really matter, so I don't quite understand what's the deal. Okay, we'll have to get back to binary sequences, but for now I feel like reading the last problem. Problem number did anyone? Oh, they already solved everything. Impressive. Okay, I must be just thinking terribly slow in the morning. That is kind of strange. Last time he could not solve this. And left the contest 1 hour in. It is kind of strange. Alright. Let's get back to minimize the product. It's also strange that he is only registered on HackerEarth. That's okay. So, sixth problem. Minimize a product. We are given an array A and of n integers. Also, we are given q queries of the following type. 1xv, change the value of x index to v. And 2lr, determine the number of pairs ij ordered in subarray such that product is minimum possible among all such possible pairs of elements. All right. So I'm thinking a segment tree because like what is the minimum product? If a subarray has like minimum product, oh wait, the values are non-negative, okay, then that's correct. So like we have an array. We got asked about a subarray, right? We know that somewhere in this subarray is minimum element of this subarray. If there is at least one more minimum element equal to this, then the only way you can get minimum product is by combining several minimums. And therefore, your answer is binomial coefficient of m by 2. Count them. So you want to count minimums. With a twist, if minimum element is unique, then you actually want to count second minimum elements. Because if there are several of them, then your answer is just count of m2. So like count of m greater than 1 than this, if count of m is equal to 1 then this. So we want to count minimum element and second minimum. Can segment tree do this? Surely it can count minimums. More complex queries. Find the you see, find the maximum number of times it appears. It is quite easy. How to count second minimum? I'm not sure. You see why finding minimum is easy. Well, we can do it in log square, right? If we just store the minimum in number of times it occurs, then we can do it in log squared. Which should be fine, to be honest. But we already saw that some things that we think are fine are not fine. But maybe there actually it matters that n was not 10 to the 5th, but p was 10 to the 6th. Maybe that mattered more. Want to determine the sum of, okay. Not exactly sure why we can't just print answer to each query, but okay. One type of the query. If type is equal to 1, otherwise type is equal to 2. Type is equal to 1, then we want to read x and v. Decrement x, and I assume that we want to call like initialize of a. So I'm by doing this part first, I'm defining the interface of segment tree that it will have to obey. Update at x to value. Otherwise, Otherwise, well, I surely want to read L and R, decrement both, I assume. Then I want to query from L to R for first minimum and the count of the first minimum. If count is greater than 1, then sum plus equals what? Count 1 times count 1 minus 1, long. Over 2. If I want to do that, should make some long. Right, that number is at most 10 to the 10th, we have at most, yes, okay, so I can just mod at the very end if I do like this. Otherwise, I want to find the second minimum and the number of times it appears. Or can I just, I wonder if I actually can do all of that in one place. All right. We have a structure of segment tree. We'll have the tree itself. We'll have constructor, which will take in size. We'll also do that. We'll have initialize, please. What's wrong with T? Oh, right. How about that? That is ridiculous, but it's okay. By the way, I apparently I drank too much tea, so I need to take a short break right now, and I will right back in a minute. Alright, so we are back at quite an hour segment tree. I actually was thinking like this is kinda simple, right? You want to write combine, then it's kinda simple. Like, because you just need to be extra cautious, you see. what is the first minimum? It's actually LM1. Yeah, by the way, we will need to write a default constructor for it. Which I think goes as follows. But I'm not so sure about it. We'll see. So what I was thinking is what is the first minimum? Just minimum of 2 minimums, right? What is the count of first minimum? Well, depends. Depends. Oh, you are absolutely right. So if minimums of both sides are equal, then it is sum of counts, right? Otherwise, we have another expression. So if left minimum is less than right minimum, kind of a nested expression, but that's what you get. Then you get left count. Otherwise, you get right count. Now, what is minimum 2? Once again, if left minimum is equal to right minimum, then it is the minimum of Actually, I started thinking that maybe it's better if we rewrite it this way. So we say like if this, else. No, we'll go with if this, else if this, else, and here we can say that they are equal. It will be more symmetric this way. What is the first minimum? Is clearly this, right? What is the first count? It is clearly left C1. I want to check who is the second minimum. If this happens, there are three cases again. Like after we took first minimum of left side, it has also a second minimum, which we may need to combine with the right minimum, the first right minimum. I know it's not pretty. There's probably a prettier way of doing this, but that's really not. So here we want to return M1, C1, left M2, left count 2. Here we want to return right minimum, left, light and left, right and right count 1. Here we want to return M1, C1. Now it doesn't really matter which minimum we choose, but what matters is that we add those together. Oh, you know what? We can do that, right? This way we are sure that we never have to look at this case. Moreover, no, here we unfortunately have to, because they are different, differently named fields. Yes, I think that combined function looks like this. A bit ugly, but sometimes you just have to do what you gotta do what you have to do what you do. Alright, and here our typical initialization goes. Apart from initialization, we'll also need to update also need query. And for all of those, we will need like versions which take three vertex, 3 left and 3 right. So those are like simple wrappers that ensure that I never miss 0, 1, 0 size minus 1. So that I don't have to type them all the time in the main program. Here I will have to return that. So initialize is like what you typically call build. And how it works, if 3 left is equal to 3 right, then we are at leaf. And 3 at 3 vertex is supposed to get... Oh, we'll also need t of int AI, which works as follows. Minimum first gets AI, C1 gets 1, minimum 2 gets infinity, C2 gets 0. Otherwise, 3 middle is 3 left left plus 3 right divided by 2. We should call initialize of 2 times 3 vertex, 3 left, 3 middle. That's it. Here vertex plus 1, 3 middle plus 1, 3 right. But also 3 at 3 vertex gets combined of 3 at 2 times 3 vertex and 3 at 2 times 3 vertex plus 1. Yes, looks like this. So update once again. If we came to a leaf and we say 3 at 3 vertex gets T of V, I assume. Otherwise, 3 middle is once again defined as 3 left plus 3 right over 2. If x is at most 3 middle, then the query goes to the left. So I should call update of 2 times 3 vertex, 3 left, 3 middle, xv. Else I should call update of vertex plus 1, 3 middle plus 1, 3 right, xv. And the end I should say that 3 at vertex gets combined, well, basically of those two. Alright, here the logic is a bit different. I believe that we usually write it like this. If this and then return t of nothing. Otherwise, if 3 left is equal to left and 3 right is equal to right, then we return 3 at 3 vertex. Otherwise, 3 middle gets 3 left plus 3 right over 2. Then we call combine of query and another query, and we return it. The queries are 2 times 3 vertex, 3 left, 3 middle, left maximum of right and 3 middle. Here 2 times 3 vertex plus 1, 3 middle plus 1, 3 right, minimum of left and 3 middle plus 1 and right. Let's check. It appears that I implemented it correctly. I was not looking here, just in case you're wondering. I want to learn, like, make sure that I can type segment 3 myself. I wonder what went wrong here. Oh, else if. Same here. Luckily, we can copy paste. Oh, I forgot to pass array A here. as reference, so it does not get copied. Don't worry about that. That is unfortunate. That is unfortunate. I wonder where it stopped. So like, did it initialize? Does initialization, okay, initialization works, but does not print anything, obviously. So something of this and this fails, right? Okay, can we just process updates? Okay, so we can process updates, but we can't process queries. So luckily the type is in query somewhere. The query goes as follows. If left is greater than right, then we return a natural element. If the segment just is equal to what we were looking for, then we return this. Otherwise, we define tree middle, yeah, and return combine of two queries. This. Oh, minimum here, maximum here. Okay. Okay, let's submit. Probably won't work the first time, but... Oh, it actually... Oh, okay. Alright, so we can write a segment tree. Not a big deal. Not anymore. That's nice to know. Well, the leaderboard has not been updated in several minutes time. But it still looks kind of odd that like only 5 people solved it. I assume that you can get 10, 20 or even 40 points by just using a big O of n times q solution. So yeah, that's impressive. We should work on binary sequences, however. So the last time we were thinking about it, we concluded that we want probably want this to make it clear. However, for memory, that's not going to be footprint. It's not going to be great, but well, you know what? You know what? You can always do that. So I should also think about initial conditions. So we are trying to do DP, right? My guess is that DP clearly needs to depend on Z, O, and K. And I want to calculate the number of sequences that have I zeros, J ones, the length of the longest non-decreasing subsequence is L, and well, the longest non-decreasing subsequence can end on either 0 or 1. Hopefully that makes sense. So therefore we have a pair here. How are the guys doing? So what I think we should be thinking like, okay, all right. So we have some info already. Let's say that DP000 is no. Let's say this and this. So we have some info already. Let's try to add a 0 to this information, right? So the only way the last 0 can get into longest sequence is if the number of zeros, so the number of zeros plus 1, I should add 1 here, 1 everywhere. Number of zeros, okay, so we add 0, append, I should even make it clearer. Append 0, we can also append 1. So the number of zeros here does not change, right? Here the number of zeros increases by 1. Here the number of ones increases by 1. Here the number of ones does not change. Here, what is K? There are two cases. So if K is less than Z plus 1, right? And K become then DP at 0 plus 1 once K no, Z plus 1 gets 1, no, gets DP and this, and 0 here. So like there is, if K is less than this, and then there is exactly one way, like maximum sequence is just all zeros. And there is exactly that many ways to get that many zeros. Else, if K is strictly greater than that, then this just gets this. Or here it should be first. No? Wait a second, what should I put here? I think I can put all of them, right? So like this. Else is interesting case. So k is equal to that plus 1. Also, I forgot to print type this here. That plus 1 or k equals like how we can end with a 0. One thing we can do this, right? We can. Oh no! Wait. Okay, we'll have to figure out all of those transitions once again. But I think that it's expect something like this. But we will have to be very careful here. How can we end with a 1? Only no, let's say that, okay, let's say that this is like what the entire sequence ends with. Will it be enough? I think it will be. So this is like what the entire sequence ends with. Therefore, here we only fill first. Alright. And here it appears that we only care about what? Well, that one changed, this one changed, there, I don't know what will happen, but we only change second, right? Oh, of course, instead of K, I should have L inside. Sorry about that. Oh, and IJ, sure, I'm super sorry. This should be I. This should be J. I mean, something like it looks suspicious, and then I realized why. I was like, oh no. Good thing that I noticed before submitting. Alright. Now we think what happens when we append 1. Probably all of those guys should be modded. Oh, here it doesn't matter. Looks like it does not matter. So okay, now we append now we append 1. So number of ones increased by 1, right? Oh, we need at least k. We need at least k. So this in fact should be like this. Oh, I forgot that we need at least k. so that we need exactly k. Not a big deal. No, but here then we also get up to this, right? These are like just safety measures. So here we take this, we also take this. I feel like some should be modded in between as well. Yes, no, of course, it has to be. Okay, if we append one increases the length of every sequence, right? Here I'm thinking maybe we can just put this here to simplify the logic. One can increase every sequence, so we always get an increase. Here, commented by dp ijl. No, that was of course incorrect. Well, that was correct. But here probably I should also consider this separately. Because, like here, if we append zeros and the length of longest subsequence with zeros is too long, right? And there should be both of those here, right? Both, regardless of what you end with, regardless of what you end with, we can always take 0. I'm struggling. I really am. Can we just say that this is like 0 instead, please? So that I don't have to go through all the pain. And then I can do this, right? Right? But here length always increases, so well, yes. So it gets incremented by dpijl and modded. Oh, I have no idea if this is going to work. Please do. Embracing class nationalists. Ah, yes. It will be so painful to debug. Remember first, yes, well, we changed that. Our code didn't print anything. Interesting. Wait a second. No, but like, if k is too big, this loop will be just empty, so there is nothing bad with it. What happened? Oh, here, oh, okay. Understandable concern. Oh, samples passed, okay. I mean, probably won't work though. No, oh, how nice. Okay. So apparently they listened to me not wanting to debug it. So yeah. Now we did this. Right. Excuse me, camera. May I get you for, yes, thank you. That's nice. Let's look how bad we are at the leaderboard. Probably Nikita already solved this problem because it's like just a simple segment tree, right? No, he's trying to do I don't know what. Wait a second, 4 seconds, right? For actually what happens then? Or he probably has some like wrong answer and not TLE. That was probably TLE, but now he has wrong answer. That's unfortunate, because like time is exactly the same as it should be. I am also impressed by how we made one wrong submission, which TL'd. Alright, so we made one wrong submission only in the contest, which is nice. Looks like we got 4th place, which we kind of don't care about, because you know the prizes are for top 3, but you can only get them when you're ranked below 1600, which is a difficult thing to do unless you lose contests on purpose. Like this guy does. Just participate in circuit, solve nothing. Here you go. Oh, submit 1. Alright. So that is very dirty, but okay. How about that guy? Once again, participated in circuits, solved one problem, I suppose, dropped the rating. I don't know what's the yeah, like oh, not every time, but sometimes they just drop the rank. See, interesting tactics there. Nice, Code Forces profile linked for once. Speaking of which, this guy is actually a Grandmaster in Code Forces, so I'm surprised that we can outperform him, as you can see. Ice Knight, familiar name. And he is actually ranked a bit higher than us. So that is not strange that he outperforms us. Nothing linked here, nothing linked here. So like top 2 guys, you don't know anything about them, they are only present on this platform. Very nice. I mean, that can be the case, but like, why don't you link other profiles? And that just unnecessarily sus. Oh, he's no longer a Grandmaster. But I mean, that can happen. That can happen to everyone. Been Grandmaster for several contests. So, more than more than me. Yeah, so, but like for us, we just don't lose contests. We don't drop ratings, so it just stonks. And it's impossible to get prizes. But that's fine. We are here not for the prizes, but for interesting problems. Also, it's nice that we... Oh, he may actually get back, right? Because he already, like, yes, if he solves it until the end of the contest, his penalty time will still be smaller because I solved the problems in the wrong order. Okay. So, let's walk through all the problems one by one again. First, smallest number. We were given a number. Excuse me. Thank you. Now the camera is doing weird stuff today. So we were given a number that consisted of like 1, 2, 3, 2, 1, 1, 2. But we noticed that those guys can never change. So there, but 2's can change with everything. So our solution was, okay, like we should put them before every 3, right? Well, let's also add another one here. So like I said, we should put them before every 3. So that gives us those 2 guys, right? But then we also should put them behind every 1 that we can put them behind, so like without the 3 getting in the way. That leads us to this. And what I said is like, okay, like this part highlighted, it is, we take only 1s and 3s and we insert them before the first 3. So nothing smart, just submit. Right. Hopefully you were able to figure out that on yourself, but yeah. Second problem, we were tasked to divide the digits of one number. So for example, like this, we wanted to split them into 2 numbers. In this case, it's 1, 2, and 3, so that the sum is minimal. What I said is like, well, we probably want to put smallest digits first, and then you want to alternatingly append them to x and to y. You can see that we ended up with different solutions than this suggests. So we ended up with 13 plus 2, but that's clearly the same. My point is like, we pair them with something like 10 to the case, 10 to the case minus 1, 10 to the case minus 1, etc. 10, 10, 1, 1. Potentially, like whether or not we have 10 to the k twice depends on whether the length of n is even or not. And then it is just rearrangement inequality that you want to, if you want to minimize that, then you want to put minimum with the biggest one and the biggest digit with the smallest power. That's rearrangement inequality, quite popular in like 8th grade Math Olympiads in Ukraine. No, like it was some time ago when I was in the high school. So yeah, I just remember it from there. If you want a formal proof, right? But if you just want the intuition, that sounds kind of like reasonable, right? You put smallest digits to highest places to minimize the sum, and then you don't care which digit out of those 2 ends up where, because they get multiplied by the same power of 10, which is 1 in this case. So this problem I probably overcomplicated. So what I did, I got my Eretus fan sieve to get all prime numbers quickly. Then what I Oh my goodness, the indentation is terrible here. Okay, so what I why did it happen to me? I don't know. So what I did, I said like, okay, dp at n will contain a map from product to number or count of such arrays with the given product of length n. And how do you live with this dp? How do you update it? When you're trying to add, you have n, right? You have your n. They said that it's a palindrome, so you know, like the first number is also going to be the last number, and here you have dp of n minus 2. The only thing you have to care about is like if you loop over all p's, then it's too long, right? So you probably want to break as soon as p times key of this map. There's key, which is the product, and there's value, which is the count. So value you will use to update your value. But key, like once you see that p times product from here times p is too much. Let's say it p1. If this is bigger than p from the statement, then we can stop the loop. We can break a looping over dp n minus 2. That probably helps. So I wonder which one's faster, like if you put those two loops in this order or the opposite one. That's an interesting exercise for you. But what I think happens, like you want to, let's say that this the size of this map is s, right? And what's the running time of our algorithm? Well, currently we have s here, right? And we also have loop over all primes. But we break whenever square roots of p1 is greater than p. So count of so we get times count of primes up to square root of p. That's like a naive bound. And times log p, right? Because that's how long n can be. Now this thing, like naive bound, suggests that count of primes of square root is at most square root, right? And s is at most p. Now this is a bit too slow for p equal to 10 to the 6. But apparently, like actually what happens here is that this is actually smaller than square root of p, right? In fact, I believe that what it is, it's like square root of p over log of square root of p, which is 1/2 of log p. So we already can forget about log, right? It cancels out, just in case you haven't noticed. It cancels out here and here. So this part already like removed the log. That we're looking over only primes. So now we have something like this, and this part is accurate. Now what is not accurate is that we actually stop for many not only we loop to square root of p, right? But for like bigger values of first, we don't loop over the entire map because it quickly gets too much. So yeah. So this is actually, so S is actually, and also S is not big. So I think that S is a bit smaller than P, right? Because a lot of values like 6, 10, 15, they can't be represented in this form. So it's interesting to know what S is, but I assume that it's significantly smaller, like P over log P. And then this is already like fast enough to pass. But also we break faster for many values for many primes, P1s, we break faster than we even loop over this small map. So that's probably why it works, but I don't have like the accurate complexity estimate. This problem is just DP. Because constraints are so small, we can DP over everything. We DP over number of zeros in our sequence, over number of ones, over length of the longest non-decreasing subsequence. We consider two cases: what happens when we append 0, when we append 1. Like those are safety measures because I didn't want to figure out where we can place less equals where we can't. So I just increased the size and computed several extra values. Yeah, and then we'll just loop over all lengths that are at least k. Nice and smart. Here, you just have to realize that it's longest increasing subsequence. Just the first array denotes the permutation. So we sort by the first array. Sort condition doesn't matter when, let's say, like if two elements in A are equal, then the corresponding elements in B can't be equal, because we don't take equal elements into strictly increasing subsequence either way. So like, nothing to do there. And then just realize that it's least and you're done. Here you understand that you need, well, first thing that you do is actually figure out this formula. You see that it depends on the number of occurrences of first minimum and second minimum. Then you think like, okay, I'm pretty sure that segment 3 can keep first minimum, right? And number of occurrences of it is classics. Then you think, okay, how can I do with second minimum and number of occurrences? Well, you just need to elongate your combine function. Hopefully by now you have seen me coding segment 3 with combine function at least 3 times. So you kind of understand how it works. This part we could have copy pasted, but I wanted to type it myself, just to get a better understanding of what actually happens. Maybe one day I will not even open CP algorithms, I will just code this by memory. Yeah. Also could have saved some time by just having a library implementation, you know? But it's a good practice. Second, I don't take HackerEarth contests seriously, right? Because that just sounds funny. All right. So hopefully that helped you. I apologize again for not releasing the video yesterday, because I was trying to upsolve AdCoder beginner contest 211, and well, was very hard for me because like first 4 problems extremely easy, but then problem E was backtracking. I'm not good at backtracking, and problem F was geometry, and it was like hard geometry, and I'm still solving it. I think that I kind of have the general idea, but the implementation is painful a bit. So yeah, and also implementation for backtracking turned out to be painful as well. So hopefully I will be able to finish it at some point, but I will likely have to just record everything from scratch, because like merging 3 parts into one video is not great. So yeah. But for me, for today, it may be all. So hopefully you enjoyed those problems as well, and I see you soon in the next one. Bye bye. Right. Now definitely bye.